LEDs can do more than simply blink on and off. They can be dimmed as well. You may be familiar with dimmer switches on some light bulbs, especially back in the incandescent days. And if you go to the store and you get your LED light bulb replacements, you'll see that a lot of them will specifically say in very large bold letters, "Not dimmable, do not use with dimmer switches." But they are dimmable. The thing is, LEDs run on direct current, and your wall is alternating current. The incandescent bulbs that used alternating current, it just went through. It didn't matter which direction it was going, even back and forth. The idea was to have resistance in the filament, which made it glow. But LEDs need direct current, so every single one of those bulbs has a little transformer in it, has a little full bridge rectifier in it, to basically convert AC to DC, and those transformers are built specifically for the voltage input, 120 or 220, that you're supposed to have coming from your wall. If you change that voltage, it's going to screw up the transformer. So you can't just vary the voltage or resistance or whatever you're physically varying like you would with an incandescent dimmer. The LED has to be dimmed directly. Now, LEDs run on current, not voltage. They're proportional to current. All diodes and transistors are. Once you have achieved a certain minimum voltage to activate them to overcome that little depletion layer we were talking about and get the quantum mechanics rolling, then it's all about the current. So for an LED, you supply the voltage that it wants. Doesn't matter how much more than that, it just is going to take the voltage it wants, and then you turn up and down the current to dim it. Or you can also just turn it on and off very rapidly. Human beings can easily see flickering at lower frame rates like 30, 60, even some people can discern flickering at 144 hertz. But when you're using something as simple as an Arduino that can flash it at 500 hertz, or even something more advanced that can flash it faster, the human being is not going to notice. So you just turn the thing on and off very rapidly, and to the human eye, it just looks brighter or dimmer. So those are the two ways you can do the dimming. Manual, with variable resistance, a potentiometer. You have a dial that can make an LED brighter or dimmer. This is useful as an actual physical dimmer switch. If you have an LED light source running off of direct current that you can directly dim, and it's useful for if you have a device that has an LED display and you might want to use it in dim conditions, you could have a little knob to turn down the LED and make it easier to see in the dark, not so glaring. And then there's the automatic way, the flashing on and off way, that you would use if you had it powered by an Arduino. So let's look at a few circuits. Let's look at the manual method first with a physical potentiometer. So you have your power source, you have your LED, you have a resistor, and a potentiometer. And you're going to use all four of these elements. Now, why would you use all four? The potentiometer is being used as a variable resistor because the power supply is always supplying the same voltage, the LED is always taking the same voltage, so the resistor is always going to take whatever's left. We're putting these in series, so they're going to be combined. Now, if you just had a potentiometer, then when you turn the potentiometer down to incredibly low, then you're going to get a lot of current because the resistance is determining the current. You've always got the same voltage here, so this always takes the leftover, which means the resistance with that voltage determines the current. Ohm's law. So if you have very little resistance, you have a lot of current. So this fixed value resistor is going to set your brightest point. So what we do to create this circuit is first just use the potentiometer. So positive power into one side of the potentiometer, and then the little wiper into the LED and back out. If we connected the power over the potentiometer and took the reading from the middle, then it would be a voltage divider. That's not what we want because we have a fixed voltage here, a fixed voltage here, and this is supposed to take the rest. So we want it as a resistor. Now the purpose of this is to figure out our brightest point. So you hook up the power, you hook up the potentiometer turned all the way to maximum resistance, hook up the LED and turn it on, then you turn down the potentiometer until the LED is as bright as you ever want it to be. Maximum brightness. I guarantee if you turn it down too far, it's going to get really bright. So you want to figure out how bright you want it to be at most. Then you just use your ohm meter to measure whatever the potentiometer is at, and then you pick the nearest resistor to it. So that means, once you have your other resistor in here, this resistor is set to the value that the potentiometer was when your LED is at the brightest, so that when this is at roughly 0 resistance, turned all the way down or up, however you put the little knob, then the LED will have only that resistance and it will be as bright as you set. And then when you turn the potentiometer all the way up, it becomes incredibly dim. Very little current, maybe not even enough current to drive the LED, but in any case, super dim. And if it's too dim, if you want it to never go completely out but just be, rather muted, then use a different potentiometer. The ones I have are all 10,000 ohm potentiometers. You can also use whatever is available, 1,000 ohm, whatever you find in the catalog. Or, since you're making a physical dial, you could put a little piece of plastic or metal or something on there so that when you try to turn it too far, it presses against it and it prevents you from turning the potentiometer all the way. So you're throwing away the potential of the potentiometer, but they're not terribly expensive. So if all you have is a 10K and you don't want it to go over 5, just make sure the dial only can turn halfway. And that's it. That's your dimmer from manual mode. What about automatic? So we have here the Arduino, which has power, and let's say here is a digital output pin. Now, the digital output pin is setting voltage relative to its 0. So the voltage on this output pin, we'll call it D1, is of course measured relative to ground. And it's basically always either the input voltage or the output. So 5 volts for an Arduino. For most Arduinos, some work at 3.3, but for the ones I have, 5 volts or 0. And it's a digital output pin. So you might say, well, why wouldn't you use an analog signal? The Arduino has analog pins. They're only for input. It has an analog to digital converter. The digital pins, if you use the analog function to say, set a pin to an analog value, which it has, you can set it to 0%, 5%, 50%, whatever, uses the digital pin. It's called pulse width modulation. I'll go into this more later. But for now, basically, pulse width modulation creates an average voltage by turning the voltage on and off like a light switch, non-dimmable, rapidly. So let's say 500 times a second, it's going to turn it on and off. And how long it stays on and off within that 1/500th of a second is based on your value. If you say, I want the voltage to always be on, I want to analog write a maximum value, then it's just going to turn the voltage on and leave it at 5. If you write a 0, it will turn it all the way down and leave it there. But let's say you write a 0.5, which on the Arduino I have would be 128, because it's a 1 byte value, an 8-bit value. So every 500th of a second, it would turn it on for half that time and off for half that time. So essentially, it's on for 1,000th of a second, a millisecond, and off for a millisecond. So if you had it at 75%, then it would be on for, 3/4 of 1/500th of a second and off for 1/4 of 500ths of a second. And so the more it's on, the more it averages out. And this works with an LED. Now you might say, well, isn't that turning on and off hard on the LED? Yes, but negligibly. As in, it will decrease the life of your LED probably by minutes, maybe hours, at a guess. Everything I've read says it's incredibly minuscule. The LED is going to naturally fail at roughly the same time whether it's being switched or not. And in fact, some spec sheets will say, like, for example, you can run 20 milliamps through this LED, but if you're switching at no pulses longer than 0.1 second, then you can use 100 milliamps, kind of thing. So it's clearly intended even by the manufacturers. So don't worry about it damaging the LED. It's really not. Not that you'd ever notice. So the switching on and off kind of blends, and it works for voltages too. If you hook up an Arduino using this pulse width modulation thing to create a voltage between 0 and 5, a regular digital multimeter will read it just fine as the voltage you intend, because it's averaging over like half a second versus 500 times a second it's being produced. So even though it sounds funky, it's perfectly fine, and that's why you don't need any sort of capacitor to smooth it out. If you had a capacitor, it would smooth it out. You could actually get a much more steady DC voltage, which you might want. It's similar to a switching power supply using capacitors to smooth that out. But you wouldn't want to do it here because you're not trying to reduce the voltage. You can use this pulse width modulation to have an effectively lower voltage, but it's not actually. It's always 5 or 0. So the LED is always on or off. And that's what we want, because if you're using this flashing method, right? Because an LED needs a certain amount of voltage to operate. If you go below that, it doesn't work. The forward voltage drop. So if you're switching it on and off with a value that's always above that, it's always turning on, and you can actually vary it all the way down smoothly to almost completely invisible. And in fact, if you set the voltage to 0, it effectively will be invisible. So it's even better than a potentiometer, because the potentiometer, is going to go up to its maximum resistance plus the fixed resistor we had in there. And it will get, possibly too dim for the human eye to see, but it'll still be on. But the bearish trickle current, if any, if you're connecting it to ground, it's just going to do nothing. If you set your value to 0, it'll just never flash the LED on. So it's really, 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 really smooth and nice and wonderful. It's really the best way to do it. And it's energy efficient. The potentiometer method uses resistance to reduce the current, and that resistance is heat. It's not going to be enough to need a heat sink. You're driving an LED. It's not going to be significant currents, but you're still wasting power. Whereas this method wastes no power at all. So we have this pin, which relative to ground can make either 5 volts or no volts. So then we have our LED. The LED is also connected, its output to the Arduino's ground. Remember, everything shares the ground. And then we're going to have our potentiometer. Wait, I have a reason for this, because this is the setup. Because you still need a resistor, right? Because while this is on, it's a short circuit without it. So what you do is you do the same thing as before. You set this output to be your maximum, your 5 volts. And you don't have to do this with the Arduino, just stick it in your power supply with 5 volts, because the Arduino is providing 5 volts. But in this case, we put the 5 volts. In fact, we could even just be more clear. We're always using max power. So we put the max power through there, same as before. And once again, we're setting the potentiometer so that the LED, when this is fully on, always providing 5 volts, is maximum brightness that we want. However bright we want it, we set the potentiometer to that. Then measure the resistance, get a resistor, and stick it in there. And then, of course, it's not connected to the positive power anymore, it's connected to the pin. And there is your dimming LED by pulse width modulation. So what happens is, if you set this pin to be 100%, then it will set it to 5 volts and stay on, or 3.3, whatever your Arduino uses, or other device, -5. So it'll set this to max power and leave it there. Every 500th of a second, it will try to, say, okay, I've got to vary it now, but it'll see, oh, I'm supposed to be at max, and it'll just leave it there. So max power will go through here, and this resistor is calibrated for max power, so your LED will be at 100% brightness. If you set it to 0%, it'll set this to 0 volts and nothing will happen, and it'll be at 0% brightness. If you set it to 50%, then half the time it will be at max brightness, and half the time it will be off. And switching at 500 or more times per second is going to be indistinguishable to the human eye. You would need a high-speed camera to even detect that. So it dims, and there's your circuits. Let's actually show you how it works. So I have here my power supply, which I've set to 5 volts and no amps, which is connected in my breadboard. So now I will add a potentiometer. If I read across this resistor, this potentiometer rather, you will see that it is putting out about 10,560 ohms. So basically it's a 10K resistor. That's its maximum value. And if I hook it up to the wiper, then the resistance is going to change. I said if I hook it up to the wiper, then the resistance is going to change down to 0 and up to here. And just to demonstrate rather, if I turn it down to 0 and to my minimum setting, we're getting only 3.3 ohms. That is not much. That is, if you have 5 volts connected to 3 ohms, 3.3 ohms, 5 volts, 3.3 ohms, you have more than 1 amp. That's a lot. Your Arduino is going to self-destruct at 200 milliamps. So this is why you need that series resistor, and why your LED will be very bright. So let's set up our circuit. So I will connect from the positive power to one of the supply pins, or pass-through pins or whatever, of the potentiometer. I will actually add an LED to the board. That would help. Let's choose a blue one, because that's my mother's favorite color. So we have an LED. So I will connect from the wiper of the potentiometer as a variable resistor to the input of the LED, the output of the LED to negative power, and turn up the current limit. But first, remember to turn up the potentiometer so you don't actually fry your device. So you will see that it's supplying less than a milliamp because this is 10,000 ohms. So let's turn it down. And let's say, see, now we're getting 2 milliamps, roughly 6 milliamps. We don't need it that bright. Let's say here, this is supposed to be an indicator, not a laser. So let's say whatever this is at, that's going to be our maximum brightness. So then we go back to our meter and let's measure with no power, just the potentiometer, what it's at. So from one pin to the other, and we're getting about 4K ohms, 4,220 ohms. So that's a lot of ohms. A lot of people are going to use resistors in the 470 to maybe 1,000 range, and they're going to get very bright LEDs. Of course, if you had a 3.3 volt power source, for example, you would use a smaller resistor. But I don't like blinding LEDs. I have a speaker that has the most blinding LED I've ever seen in my life. I put a piece of duct tape, it was literally distracting just being there. I put a little cutout square of duct tape, you know, that stuff, it's pretty thick, and put it over that, and it shines through at about the brightness it should have been. So yeah, I just don't like them too bright. But you can make them whatever brightness you want. So what we do now is we go in our resistor box and we say we want 4.2 some K ohms. Now the closest we're going to get is either 3.9 or 4.7. I guess we'll go with 3.9 and we'll make it a little brighter. So we'll get a 3.9 K ohm resistor out, stick it in our board. So then we'll change this wiring, and we don't need this anymore. So we'll change the wiring to go from positive power into the potentiometer, through the potentiometer. In fact, let's hook it up like I had it before. So from positive power to the fixed resistor, from the fixed resistor, it doesn't matter what order you do these in, as long as they're in series. I just like doing it this way. I like doing things in sort of the order I imagine them operating in, which is nonsense because conventional current is opposite the actual electron flow, so it really means nothing whatsoever. Call it the placebo effect. So we'll connect from the other end of the resistor into the potentiometer, and then from the wiper of the potentiometer to the LED input, and the LED output to negative power. So now, turn our current back up, you can see the LED doesn't want to light because I put the wire in the wrong place as usual, and actually turned out to be a wiggly wire. These are good wires, but they are very fragile and I'm not too good on them, so this one goes in the rubbish bin. And now let's hook up the circuit properly. Learn from my mistakes. The first thing you do is check to make sure you wired it correctly. The second thing you do is make sure your wires are working. Then the third thing is crawl in a ball and cry. So now as we see, we're going through both resistors, and if I turn the potentiometer all the way down, we're not drawing crazy current, it's about as bright as it was. Turn the potentiometer all the way up, and it gets pretty dim. So you see, it doesn't go all the way off. In fact, I expected it to be a lot more dim than that, but I guess 14,000 ohms goes only so far. This must be a pretty good LED, but it dims. So you'd actually want to use a bigger potentiometer, or use the automatic method. That's much easier. So let's do that. And for that, we won't need our power supply. So I have here a laptop computer. Handy thing to have. I also have an Arduino. Operating and powering the Arduino is simple. You just plug it in by USB. So let's move this over. Now, I'm not going to try and film my laptop screen. I'm not one of those guys. Right now, I'm not going to show you anything on the laptop, so it doesn't matter. You don't even have to look at that. But at whatever point I show you Arduino programming, I will be actually using something like OBS to capture the laptop and show you the actual footage. So anyway, you just plug the USB into the laptop, or whatever, anything that uses USB, plug it in there, and there we go. We have a working Arduino. So it is taking the 5 volt and ground lines through this wire that are being created by the power supply of the laptop, and it also breaks out. You can access that 5 volts and 0 volts ground by some of these headers. Now remember, you can only draw so much current through this Arduino. If you were driving something high powered, like a motor, then you would want to use a transistor, have the Arduino control a transistor. But we're doing an LED, that's perfectly fine. It's even got LEDs on it. So now we'll bring over our breadboard, take out the power supply for now, and now I'm going to connect the power through the Arduino. So I will take a line labeled 5 volts as my power supply, and I will connect back to the Arduino to one labeled ground. Let's use the meter to confirm we're getting 5 volts. Be careful with your wires. I just shorted it out to the ground and it disconnected the Arduino. So make sure you're actually using the wires from your multimeter rather than your turned off power supply. Ah, the joys of a messy table. So now we will measure the voltage, which is 4.96. As usual, close enough. So we don't need to measure the resistor again. We already determined, because we were using 5 volts before, we're using 5 volts now. So this resistor is about how bright bright we want it at maximum. So we'll connect from the positive Arduino power to that resistor. Again, if you hadn't done this, you just configure it with the potentiometer just like the other way, using the Arduino's power instead of a power supply you might not have. This is handy. You can grab an Arduino for a regulated 5-volt power supply or a breakout for a USB cable. You're not going to get the amperage because this can supply 5 amps. This definitely cannot. But for stuff like this, you don't need that amperage. So from the fixed resistor, not to the potentiometer, directly to the LED. And then from the LED back to power. And you will see it lights up. But we're not trying to drive it that way. We're trying to drive it by a variable output, by the PWM. So instead of connecting it to positive power through the resistors, in fact, we can even take the positive power pin out. We only need the ground connection. We're going to instead connect it to a digital output pin. Where did I just put my wire? What is my life? When in doubt, get a new one from the box. So the input, it still have plugged into the board. Like I said, what is my life? So the input is going to be, in this case, on the Arduino, there's a little spot, there's a little indication of which pins support PWM. So let's do pin 11, which supports PWM input. And you notice it does not light on. So I'm now going to write a very quick and easy Arduino program. Again, I'll show you Arduino programming later. For now, don't worry about it. So pin mode, pin 11, output. And then digital write, pin 11, high. It's compiling, give it a second. And now it compiled the program, uploaded it to the Arduino, and now it is writing a high value of on to this pin. If I change that to low, so it's writing 5 volts right now, and I upload that one, it's faster to compile the second time, now it's off. So this is what we're going to be switching. So instead, I'm going to say analog write, pin 11, 255. So what I have done is I have set up the pulse width modulation at 100%. Again, it's staying on. This is showing that at 100% it does work. What if I say 0? I upload and set it to 0, and there you go. Now, 128. So because the values go from 0 to 255, 128 is about in the middle. And if I do that, we have a dimmer LED. What about 64? Dimmer still. What about 5? See, now you can really see the difference. I'm using a very big resistor, as we've mentioned, so it's hard to tell. In fact, I'm being an idiot. If we do this, it'll be a lot easier to see the changes. So let's change it back up to 128 and upload. So that's about half brightness, 255. Max brightness. Watch it closely, it should get brighter, at least a little bit. It's definitely brighter, you can see it in the dark, now that I'm using my brain. Let's set it to 64. There you go. Let's set it to 15. And this is how you can vary it. In fact, let me create a quick little program. Now, would you look at that? I have just created a quick program that starts at 0 and goes up to 255. Between each value, it waits 10 milliseconds. And you can see it goes down and brightens up. And our vision is logarithmic, just like most of our senses. I can't see my finger anymore. Let's have some light. You can still see it dimming. So the smaller it is, the smaller the change, the more we notice it. Once it gets bright, it's hard to tell the difference in brightness. So you might want to use a logarithmic function in here to adjust the brightness, just like your volume knob. In your normal operating system, change your volume. When you're at a low volume and change it by one little notch, you can notice a pretty big difference. You know, it's still quiet, but it's a big difference in how quiet. But way at the top, if you turn it all the way up and you change it by one notch, it's sometimes hard to tell it changed at all. So you might want to account for that, and in fact, game engines, video game engines, have accounted for this for a while, and monitors in general, by something called gamma, which curves the lower values of brightness based on how CRTs are into them. But in any case, I have explained my point. So it's very simple. It is one ground connection, which you can split amongst anything, so that doesn't really count. You can have as many ground connections as you want. So really, it's one digital pin in a microcontroller, and it's 2 lines of code. Only 1 line of code in a loop, and you have a dimmable LED. And that's it. You can now set up and deploy dimmable LEDs, both with physical dimmer switches and with your Arduino. So you can configure your device to work in a low light environment by turning down or allowing the user to turn down its indicator light so it isn't glaring in the middle of the night. Or you can use it as a nightlight where you turn the LED on when a photosensor goes off. Or you can use it as an indicator where you have the brightness of the LED indicate more or less activity. And if you want more than one LED, just connect them in parallel. One resistor per LED and one digital pin per LED. And you might say, oh, there's nowhere near enough digital pins. You can't just use a digital pin for every little thing. Microcontrollers have only so many. This is true. This is why shift registers were invented. Many, many, many videos to come about all kinds of ways to control LEDs and everything else. Until then, be seeing you.